Hello. Hello, how are you? We're good. How are you? Hanging in there, as you know. We're together once again. Once you're ready, you can get started sharing your screen. Hello, everyone. I had made a small mistake in giving the title, so it's not 2012, it's 2021.2. So in 2012, we were perhaps at the 5th version. So today, I'm going to talk about the last developments in HDRP, where we're headed. I'd like to give you some clues. And as you know, Unity had its new logo a week ago. There are a lot of reasons for them, but the biggest reason perhaps is the purchases that it made in the last 2 years. It grew a lot bigger now, and it started offering solutions to many sectors. It was doing that, but it is more clear now in that we are a company that is known in the Autodesk community. So I can say that there's an Autodesk University activity, and I presented a speech there. And Unity has been attending those events for a long time. So Unity is going to enter our houses like Paint, like AutoCAD, because we're having very different solutions with Unity. Different things are waiting for us with Unity. There was a letter in 2015. The Facebook intended to purchase Unity, and Unity rejected that, which was obviously the right choice. So I wanted you to realize once again what kind of program you are using. So in 2021.2, I'm going to talk about the HDRP version in that program. We have slight changes. I'm going to expand on them. Of course, the biggest change is the clouds. You see the clouds? They are much more realistic. They're rendered in a much more realistic way. See how beautiful they are. We're going to play with those clouds. We're going to change them. We're going to look into their properties. Unity started emphasizing on photorealness because it opened up for the use of civil engineers and architects. So we are more largely interested in the game production side of Unity, but at the global level, the games are making about 50% of Unity's income, especially in terms of licensing. After the clouds, we have lens players. I'm going to show you how to produce one. We can make any game object a lens player. I'm going to show you how. It's very simple. We added a function called light anchor. It allows you to position the lights based on the position in the world at the local level. So these are basically helper components. They help you. They're not going to create a huge difference, but if you're working in a cinematic fashion, if you're working with cutscenes, you might need them for that kind of work, and it would facilitate your business. Another function is DLSS. I'm going to talk about that. DLSS is not just only in NVIDIA cards. We have NVIDIA FX. So if you have light following cards, you can use these effects in Unity. I have NVIDIA 360, so I'm not going to be able to show that, but I can say it works in a very similar way. Other than that, we're going to talk about pair tracing. It's not very reasonable based on this infrastructure, but slowly, but surely we have to provide high quality output with Unity because its user area diversified a lot. Rather than the real-time render, we can have a static render. And this is the kind of structure that we are evolving into. It's going to turn into a software like AutoCAD. It is basically going to stay in your pocket and you're going to be able to use it whenever you want. I'm going to show you debug modes when we're using HDRP stay in your visual, especially when you use weight trace. To what extent you can perceive it or not, I'm going to show you that. And I'm going to show you how to position that in the physical camera. At the beginning of my speech, I said, I did this one, you know, from Unity Hub, you can open it in alpha as well, but this is in the beta. From an HDRP template, I opened the project and my HDRP template project is right on my screen. If you're not in 2021.2, you're not going to be seeing these clouds. So we're not in the right version now. Let's start with looking into clouds. I go into my volumes here. Very briefly, let me tell you that HDRP works with volumes. I mentioned that before, but let me cover it again. You see three different gray areas. This is a template, by the way. The first one is here, the second is here, the third one is here. So we have three volumes, room 1, room 2, and room 3. Within them, they have smaller volumes as well. The aim of these volumes is adding different properties into our areas. We have this many properties. I can open it or close it, to change the properties. So once you globalize the volume, the things that we define as words, you start placing the valid properties that are good across the whole Unity. So in here, the area that we define as room 1, we have a box collider here, and once you go into that collider, you're inside that volume. Once you leave it, if there's no other collider around you, within the camera view, that means you're in the global. So this is a set, this is another set. I'm in the global set, in the universal set, but we have subsets here as well. When I go into a subset, if I have a specific setting, for example, if I, for example, did it between exposure and white, they would work around here, and this is how the volume works. Maybe you didn't do it before, so I wanted to remind you. So I'm gonna go into global now. When we work volumes, we create a profile here. This is in a way similar to post-processing stack. In the lower part, we have overrides. Adding these overrides, we're adding properties to our volume. In the last version, we have an addition that is called Volumetric Clouds. You can remove it as well. In the old version, we didn't have something like that anyway. So we had a physically based sky. We had a procedurally generated sky. It's a procedural now on the screen. To add cloud, let's say we don't have anything like that. We're going to do it from scratch. I choose volumetric clouds here. Just let me remind you again, this is the preview. I can open volumetric clouds here, and click it on here, so everything is going to be ticked automatically. So to enable it, you're going to have to click on the other box as well. This is kind of making me a bit angry because we need another volume here. Why do we need another volume here? But it's interesting. It's kind of funny in itself. So when we open that up, the algorithm makes the volumetric clouds. So we have high quality clouds here, and we have different modes, by the way. We have different codes as well. No, it could be simple, advanced, or manual. Let's start with the simple. If you want cloudy, okay, you have the cloudy. So we're kind of providing the weathercast. Let's say we have little clouds, or let's have it very closed. The news, for example, about the weather, they affect the overall light as well. We can have dark cloud, for example, or you can customize it all together. And customization allows you to give certain curves, and based on the mathematical functions, you can establish, you can create clouds, and it would give you different outputs. If you play with offset X, Z, for example, or I can deal with its width or depth, less or more erosion, for example. We would have more void. You can give earth curvature based on that. The type of the cloud is going to change, of course. The lowest cloud altitude, should it be, would it be too low or too high? We can arrange that. Cloud thickness can also be adjusted. It can be arranged. There's maximum values. We don't see them here, but you can learn it by trial. If you exceed them, it's not gonna function. It's not gonna work. Means wind speed. There's a wind model. You can provide wind, and where can we use this wind? We have certain vegetation engine to use that. You can use it in the terrain. You can make certain things move with them, as you see here. Taking shape offset, I can change the position of the clouds on X and Z dimensions. So if you want to create a cloud motion, yes, we can do that. On the quality part, temporal accumulation factor is an aspect. Before rendering a texture, for example, we want the computer to focus on places whose visual does not change. When you're watching DivX, for example, in the old format, it allowed us to record lower quality than the DVD. So the square that we use sequentially, they had similar pixels to each other. So if you're going to use the same camera angle for about, let's say, 1 minute in that camera, in that stage, it is highly likely that we would have the same pixel in the same place. So with this temporal accumulation technique, we would process the recorded bitmaps, and we can basically estimate that this specific pixel is going to be there. So based on that, we can speed our render. We can speed up our rendering process. We can make it very high or very low. Playing with them, you can see it for yourself that sometimes you're going to realize it for yourself. You will see that some adjustment is going to work for you, some will not. Other than that, how much light is going to be given, we can adjust it. Our clouds give ambient light. and this adds to their realness. Other than that, scatter could be adjusted, erosion occlusion could be adjusted, and if we want, we can open cloud shadows. That is, if you want to give an exact photorealistic output. So you can reflect their shadow on a specific ground, and we can change its resolution here. Let's move on with advanced here. As you see, things change a bit here. It allows us to work in a higher quality. Normally, when we work with clouds, as they are very complicated, we don't want to define them with meshes because it takes a lot of time to render the meshes. So there are things that we can do here. We have a Timulus map. It's a basic map that we have, and it is the cloud layer distribution. It is a texture that we're going to use to render the clouds that are closer to us. I selected a picture. I see a cloud formation here. What is it going to look like? It's going to look like the texture that I selected. Taking this texture as an example, it created a long cloud that extends infinitely. So it's up to you. You can change, you can use map multiplier as well. So on the same plane, you can have more or less cloud. Let me select something else. One bush, it's like a straight line. I'm looking if there's anything weirder. As you see, you can download maps from internet and create different outputs with different maps. With AutoStaters, you can do the creation of higher clouds. I mean, you can work with clouds at the higher layer, higher altitude. Let's have a different selection here. The upper layer and the lower layer. You can arrange it like that. Let me change the position of the camera. I have a different debugger here. I'm going to see it now. Do I have something strange about my camera? I'm checking that. All right, I have no problem with my camera now. This is the output provided by my camera. We can change the shape factor here. We can make it denser. See, the denser, the darker. So they behave in a very realistic way. And about architecture visualization, we have a lot of tools. These are ready-made tools that we can use. And this is good news. in the architectural terms, there's a frequently used tool. Lumion is one of them. You know, it's a closed game engine. It doesn't have APA. It is only used for visualization. It provides great outputs, and it's a very easy program, but you cannot really program it. So in general terms, companies, that is, if they have people with the knowledge of programming, they tend towards Unity or Unreal, especially with architectural programming. You know, Unity caught up with a lot of things from here. That's what we understand from what I said. And once you do the changes, and it could take a bit time for real-time results. For comparative purposes, let me just tell you that when you're working with such programs, to get them as a basis, you know, we need to show the content of the program that we use. For example, I have a single core 3.7 gigahertz with 12 CPU, you know, 6 physical, 6 virtual. And I have 2 RAMs with 16 gigabytes each. And I have 3600 RTX. You know, on my computer, things are done very fast. So, I mean, so you would compare your output time with mine. This is why I showed the properties of my computer in formal terms. In general terms, this is how the cloud controllers work. When you go into manual, you know, we have cloud, look, we have a lookup table here. You can give cloud as a texture. Of course, we need to find cloud texture here. So we have 3 different options here, and we can create clouds easily, but the simple view is going to be enough for most of us, especially for those who work with visualization. This was one of the best additions. Let me just show you Lenswear a bit. For example, let's say I'll bring sun from somewhere, and I create an empty object. So as I said, lens flares could be related to any gaming object. I call it flare. I'll bring it up here. You can ask this question, you know, I'm trying to position that, but I cannot really locate on top of something. Very simple. Once the game object is selected, you click on V, the button V, and it allows you to choose the vertex, this shape. And then you click on the left arrow, and then you can basically position where your mouse does rake at. I'm gonna position it here, right on top of the wall. I positioned it. If you want to see the points from here, you can have a shared white frame. See the triangles here? The edges are vertexes, and triangles are called strides. The camera is a bit low now. Let me bring it back. You see, let's look into stats. The tries 357K is being rendered here. You see the triangles very easily, and the points here are the connection points of them. In the old versions, on the right side, it says shaded when you select it. You can select the others as well. You can see the wireframe. You can see in different ways. If you have bakelite map, you can see them as well. So we call this debug mode. This is the main debug mode. I'm going to show you the debug area in the render map. You know, sometimes when it opened up for the first time, it may require longer time to render. You see, it's white altogether because there's a lot of light. And the reason for that is that whoever has created this used a lot of light from the directional light. So I'm positioning lens flare over here. On the right side, I'm coming to the component part and I choose lens. We have two lens flares. The one that I'm going to use right now is SRP. It is scriptable in the URP and HDRP. It works in both. So I click on that. And I'd like to get a lens data. I have two, fully count or smartphone smudge. What's your expectation with the lens flare? The sunlight, we want to simulate the sunlight coming through the lens. See, we have chromatic aberrations, we have round shapes, and we have a high quality visual as a lens flare. Even if you don't look into lens flare with your camera, you're going to be seeing it. Again, it's going to still keep visible. So we have good properties, and once you look into that, you see the outcome, the outputs of that. You can change it with scripts, by the way. You can change the intensity. You can make it more or less intense. Up to you. But the attenuation distance, you know, until what length is it gonna work? I made it 10 meters. After 10 meters, it falls off. So it decreases and then disappears altogether. We can adjust them. You can give distance curve. How would the attenuation decrease, for example? You can look into that. Like 10 meters is all right, but would it decrease gradually or not? For example, you can change the shape of the curve. Other than that, you can say, all right, it's beautiful, but how are we going to create a lens flare? There's a ready-made one here. On top of that, we can do adjustments to the best of our purposes. I make one extra and I'm going to assign it here. I'm changing the poly count. The lens flare has elements under it here. I can make changes in these elements, each one of them. For example, the round or rectangular shapes, polygons, for example. Well, you can arrange them, you can adjust them. I shot one of them off, for example, the white ones disappeared. I can increase or decrease them as well, as you see. I can change the intensity. I can change the tint. Tint is at alpha here. Let me just change its color. It's white now. In a similar fashion, I can change the other elements as well. I can select circle here, or I can add something that I would like to draw. You don't have to have a realistic layer, by the way. You can provide different outputs here. Once you go inside, you would see a lot of developed properties, tint, intensity, uniform scales. The scales should be uniform, or they should be in a different shape. Where would the starting position be? You can change them. Angular offset, if there is, can provide offset like that. The pinks are more visible here. See, I can see it very easily. Blend mode, screen blend mode, pre-multiply, primary interpolation editing. These are the modes that we know from Photoshop. Are we going to give a gradient effect or not? If we are, how is it going to be? So we have a lot of properties here. So you can create this lens flare in the way that you please. If it is in the space, for example, you can use a different color. The one in the world could be different. Let's say you are going to create a neon planet and you want to provide a cyberpunk visual. So maybe in that case, the flare could be more visible, stronger. So we have very beautiful properties here. So it basically keeps moving with me. It's a beautiful function. Let me talk about light anchors.
I will produce a strong light here for the light anchors. Here is one spotlight. I will enhance the lumen part so that it will be visible. In reality, such high illuminating objects do not exist. How to use light anchor is quite simple. When there is any light component in an object, you can see here is such an object. We just do add component and light anchor is selected in the pop-up window, and light anchor is the anchor, Accordingly, we just change the lights and anchors are exactly the same. We can also input these manually. We can change the orbits like this. In the area that I exist at the horizontal platform, my angle is 78 degrees. We can also change the elevation. And with these anchors, a more comfortable positioning is possible about the lights. There are certain common points. For example, an object is to be illuminated. From which side of the object you want the light to come through. So such selections are possible here, and you can also use the presets in the table. Simply put, if you're going to do this cinematographic, you can use such tools. Or if you're going to do some cutscene, these tools can be used. Let me talk about DLSS a little bit. First, I want to show you how Retrace works and then what can we do about with DLSS. Why the light is reflected here. Let's try this. Here you can see the reflection. It must be uploaded with the ceiling. It's not uploaded, you see. We need to fix it. Yes, when you're in the scene, there are many details here. For example, there are some stamps out of the scene. In some presentations, I already mentioned about these stamps when there are some reality elements to add, such as rust or dust. For example, on this wall, this is a decal, and if you move this here back and forth, you can see that there is a beam moving, and therefore it enhances the reality of the scene. These are really simple tricks. So simply put, but they are really effective. I recommend you to use it. There may also be people using ERP, and this feature exists in ERP as well. Let's see how ray tracing works. We are in DirectX 11, and here ray tracing is not working. We need to continue with DirectX 12. And it's simpler here. I will show you how it is done. Window. Click on the window, rendering and HDRP wizard. There's a pop-up window in this HDRP wizard. It has evolved actually. First, the materials were just converted from standard to HDRP, but here, if you are going to use HDRP with VR or DX12, there is a check-in platform. Here you can see in HDRP, everything seems to be ready, but if I'm going to continue with the X12, I need to change something. There are some features which are not available in the X12. I need to open them one by one. There is just one button to click on, FXO. It does the necessary changes, and I am changing my graphic platform as well. Therefore, I need to restart my platform. By the way, is there any questions? I guess no. I'm just restarting. Yes, it has started. You can see the X12 here. And after this, there are a few things to do. Retracing will not work immediately. In order to make it work, we need to go to the project settings first. And in the project settings, I need to see which project settings to choose, HDRP or Codeo. I selected this one, HDRP, and all the features must be available. All the RTX features must be available. And here we see screen space, ambient occlusion, screen space, global reflection, as one of the most important RTX features, and also under transparency. There are two cues, opaque and transparent. These two are changing depending on the rendering of the materials that you use. I will also make them available. And finally, screen space shadows will be opened and available, and they will also ensure to get real-time estimated shadows. And especially while working real-time, when we look at the hardware that we are using at the moment, these are not adequate sometimes. Behind some options, you may get slower. And if the game companies are producing games, they use some tricks, therefore. For example, this area can be controlled. And here I want to show you something. First, in random pipeline asset, all the real-time features are available. If you want to use them, you need to check the volume. The first thing I'm going to do in Retracing is that there are sometimes some spaces here. First, I will not go to Retracing directly, but I will open space global illumination. What does it mean? The real-time lights will be estimated as a ray trace out of the box. If you want to say that I do not want to go into further details, I want everyone to be estimated automatically, this feature allows you to do so. But if I pick ray matching here, the output will be not so good. This is another algorithm. You can, of course, change the quality of this, but we're going to do ray tracing. Let's open ray tracing. And with the quality, we're going to move. You will see that my PC is also slowing down when I open it, but I just want to show you the outcome. Now you can see the estimation time, 174 milliseconds. Let me calculate it. It's around 13 frame seconds. So the screen space global illumination will estimate all the ray casts in your scene, and it is continuously done. Therefore, the computer is slowing down. Again, I'm coming to global volume. What can we do here? For the game, so we have a performance mode. When we are in the performance mode, with a slower ray tracing, we can increase our performance. There is still a ray tracing, but you can see that our estimation periods decreased from 70 milliseconds to 10 milliseconds. I'm still using my ray tracing, but it's not that strong. And here, even in the mode part, I choose high performance. It will also be good. Generally, high quality ray tracing is not used for the games. Let me give an example for high quality ray tracing. There is one builder's journey of Lego. Especially if you have ray tracing cards, buy it, it's really fun. Let's continue at quality part. if you're going to use quality and if we do not have a screen card to operate with high resolution, then we can choose this quality. When you use this, when you do this, one ray proceeds for 5 or 2 meters, for example. When we decrease the ray cast, the surrounding changes. You can see the darkening here. It's quite faint. Look, all of a sudden, it got lighter because the light only followed the ray cast for 1 meter instead of 50 meters. And therefore, the outcome becomes a bad visual. And here was the sample count. The sample count, when you increase the sample count, your image will get even slower. The SSDI is continuously operating. Here, the count is significant here. How many times the light is going to leap? It may be for 1 time or for 8 times. You need a well-performing PC. For making the light bounce for 8 times. Yes, as you can see, the SSDI part is forcing your computer. Just let me show you another opportunity, and then I will show you the SSD. Tolgay, our time is nearly up. Okay, then let's stop here. In another occasion, I can show you the other features. Okay, thank you very much for your workshop. Thank you very much for your invitation. See you.